Okay, let's take the letters A, B, and C. And we're going to think about this like we have a bucket of A's to begin and a bucket of B's, B's, and a bucket of C's. And there's just so many of those in there. And we're going to ask ourselves, how many different ways we can arrange the letters A, B, C? Well, there's a bunch of different things we can ask. We can ask ourselves, are we allowed to repeat? Does the order matter? Etc. So there's going to be big questions. Can we repeat? Are there any restrictions? And does the order matter? Well, let's start with no restrictions, repeats allowed. Well, let's go with the fundamental counting principle, blank times blank times blank. And underneath the first blank, I can choose an A or a B or a C, and that's 3 options. And underneath the second blank, well, I can be an A or a B or a C, and that's 3 options. I didn't use up my A, I have a bucket of them. And the third blank, I have again A, B, and C, which is 3 options, and 3 times 3 times 3 is 27. 27 options. And if you want to look in the notes, you can do A, and A, B, 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 and C, 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 and A, B, and A, B, A, etc. And you can see in the notes that I've drawn out all of those, and that's also equal to 27. So lots of different ways we can check our answer. Again, we can do this in so many different ways. I could draw a tree diagram with ABC, 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 etc. But either way, those are the 27 options off to the right. So that was repeats allowed, no restrictions. I have a bucket of each. Now I just have an A, a B, and a C. And I'm not allowed to repeat. And we're going to break this up into 2 different categories. 2 different categories. So we're going to do 2 questions in a row. And it's the same thing. So we have both scenarios. We have an A, B, and a C. And in the top example, it's called a permutation, where a particular order matters. So what does that mean? Well, blank times blank times blank, times blank, comma, whichever. So the first blank, I have an A or a B or a C. Now, that's 3 different options. So 3 options. Now, no repeats. So let's say, for example, I use the A. Well, now I still have the B and the C. So those are the things that I have. So I'm going to put those below. And that's 2 options. Then let's say, for example, I decide to use the B. Then all I have left is the C, and that's going to be my third option, and that's 1 option, and that's 3 times 2 times 1 is 6. And that means that we have A, B, C, and A, C, B, and A, A, C, B, and B, C, A, and B, A, C, and C, B, A, and C, A, B. For a total of, again, 6 options with no repeats like we were allowed before. Now there's some interesting notation, and that's permutation notation, which is, the formula is NPR is equal to N factorial over N minus R factorial. I'm going to move this down a little bit. I shouldn't have put it there so soon. Excuse me. So, now using this formula. So, N is the number of things we have to choose from, and we're choosing from A, B, and C, so we have 3 things to choose from. P, I'm going to draw that 3 a little bit better. 3P, and I'm choosing 3 of them. And following the formula, that's 3 factorial over, I'm going to design this page a little bit differently. I'm going to do the other example off to the right so I can go down the page like we like. 3 factorial over 3 minus 3 factorial. Well, that's simply 3 factorial over 3 minus 3 is 0 factorial, which is 1, and 3 factorial is 3 times 2 times 1 over 1, which is equal to 6. 6. The same big red off to the right, 6, as we got before. Now I'm just learning, so I'm just figuring out how to arrange all this stuff on the page better, but I realize that given that stuff is above, I should put it above. So that is if we have a particular order that matters. Now what if I just said to you off to the right, A, B, C is equal to B, C, A for some reason, like they're not different, which is equal to C, A, B, which is equal to all the others from above. Well, that's called a combination. Now, why would we be doing this example? We know there's just one way. Well, we're going to be doing more examples in the future, so I'm introducing these more simple concepts so we can understand them on the simple examples and then apply them to the more difficult examples. So now we again have A, B, and C. But this time order doesn't matter. And we don't have a way to use blanks or a tree for this. We simply just have permutation combinatorics notation. And this time, we're above in red. I'm going to put a box around that formula. It's on our formula sheet. From above, NPR equals n factorial over n minus r, all factorial. We now have a new formula, NCR equals n factorial over the same n minus r factorial, but we also have another r factorial on the bottom. So let's work that one out. Well, again, we have 3 things to choose from, and notice it sounds the same, but now we're choosing 3 of them again, but this time the order doesn't matter. So A, B, and C are the same as B, C, A. So now I'm going to substitute in the formula 3 factorial over 3 minus 3 factorial. Also on the bottom, another 3 factorial. And if you want to work that out or follow through the notes, it is equal to 1. As we saw off to the right, there is one way for that. I'm going to do better page layout in the future. So 3 different ways we can see a very similar example. We have to be aware as to whether or not at the top we are allowed to repeat. In the middle, where a particular order matters, where off to the right, A, B, C and A, C, B and all those are different. And then the example at the bottom, where there's one example where A, B, and C off to the right and B, C, A and everything is all the same. One example. Now we're going to do a very similar example with A, B, and C, and we're going to see a lot more how these formulas are going to be useful, but not to forget blanks and whatnot. Okay, so we're doing exactly the same example from the page before with the letters A, B, and C, but this time we're choosing 2 of them. So 2 things. So I'm not going to go as far into detail as to the types of examples we can have. But again, the top one is repeats are allowed or no restrictions. So blank, comma, blank. And for the first one, I have A, B, or C. And again, and that's 3. And again, I have A, B, or C, and that's 3, which is equal to 9. And off to the right, we've got A, and B, and C, and A, B, etc. And if you look up for the notes, that is 9 examples, the same 9 that we got earlier. So now let's look at no repeats and 2 different examples. So let's start off again with the letters A, B, and C. And we're going to start off with a permutation where the order matters, particular order matters, and no repeats. So again, 2 blanks. And the first one I have A, comma, B, comma, C. And then let's say, for example, I use B this time. Well, then I have A and C left. So I have A and C, which is 3 examples in the first, and then only A and C for 2 examples in the second, which is 6. Where before I had A and B and B and C and C, and A and B and B and A and B and C and C and B, etc. I'm going to look at the notes. C and B, and then C and A, and then B, and then A. I did that in a terrible order. Look at the notes. It's way more systematic. Where there used to be 9 examples, but now I'm not allowed to repeat. So I don't have the first 3. So I no longer have 9. I've erased the 9 off to the right, and now we have 6 examples. 6 examples. Where the particular order matters, and AB is different than BA, etc. So now let's take a look with permutation notation. So NPR is equal to n factorial over n minus r, all factorial. And we have 3 things to choose from, A, B, C. N is the number of things we're choosing from. We're choosing, we still say P for choose. P just means particular order matters, where C means order doesn't matter. So P, now I'm choosing 2 of them. And if I fill in the formula, I get 3 factorial over 3 minus 2, all factorial, times r, which is 2 factorial on the bottom. I'm going to go to the right this time, just the way the notes work. 3 factorial is 3 times 2 times 1. 3 minus 2 factorial is 1 factorial, which is 1. And 2 factorial is 2 times 1, and I can cross off. And I'm left with, 3. This is going to happen. This is great. I want you to watch this. This is happening all the time. I wrote the formula down, but then due to the fact that I did the question on the last time, I incorrectly did a part of it. I want you to notice this stuff. This happens occasionally with teachers, and I would rather you be on edge sometimes to go, wait, why did that happen? It's not the same answer as above. I'm going to redo part of it. So I'm going to erase the 3. I'm going to erase the fraction. Now, where's the problem? I've got that extra 2 factorial on the bottom because I was thinking in my head it might have been a C formula from down below. I'm going to erase that 2 factorial from the bottom and continue. Equals on the top, 3 times 2 times 1 over 3 minus 2 is 1. Factorial is just 1. 3 times 2 times 1 is 6, the same 6 as we did above. Now let's take the letters A, B, C again. And this time, order doesn't matter. Order doesn't matter. So on the page before that, when order didn't matter, when we chose A, B, and C, how many different ways we can arrange them? Well, any way we choose A, B, and C, interchangeably B, C, A, it's all the same. But now, if we choose them 2 at a time, arranging 2 of the letters at a time. Well, again, I can't use blanks for combinations. You can, but it's actually a little more complicated. And then I'm going to say NCR equals n factorial over n minus r factorial, seen in our notes and on the formula sheet. And I'm choosing 3, 2 at a time. I have forgotten about the r factorial on the bottom of the fraction. Just wrote it above. It's going to happen all the time. Make sure you write your formulas down. Make sure that you look at the formula sheet. Make sure it's the same. That's exactly the accident I made earlier today. Watch out for that. 3 factorial over 3 minus 2, brackets around it factorial, with another 2 factorial on the bottom, which is equal to 3 times 2 times 1 over 1 fact 2 times 1 cross equals 3. And I'm going to do them off to the right. We have A and B, which is equal to BA. So that's just 1, so I'm not going to write it. Then I have AC, which is equal to CA, because order doesn't matter. And BC is equal to CB, so BC, which is 3 examples that we got. So see the similarities and differences between the 2 last questions. We have A, B, and C, whether or not repeats are allowed, and how many numbers we're choosing at a time, and whether or not a particular order matters or doesn't matter. Okay, how many digits can we make from the numbers 1, 2, and 3 with no repeats? No repeats. So, lots of times we have to assume what they mean. So we have to first think they've eliminated repeats for us. We don't have to worry about that. But we need to think, does order matter or not? So we need to think, is 1, 2, 3 equal to 2, 3, 1, for example? Is that the same or not the same? So let's say it's not the same. And let's call it a permutation and say that order matters. Well, let's go for blank, comma, blank, comma, blank. Sometimes the layout in the notes is going to be a little bit different than the way I do it up on the board. But we can choose a 1 or a 2 or a 3, which is 3 options. Then they said no repeats. Now, lots of times they're not going to let us know whether or not we're allowed to use repeats or not, and we just have to infer. So I can't repeat the 3, so then I have a 1 and a 2, which is 2 options, and then let's say I choose the 1, then I just have the 2, which is 1 option, which is 6. And in the notes, you can see 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, also 6, the same 6 as I got previously. We can also use permutation notation. So the formula NPR is equal to n factorial over n minus r factorial. I'm not going to mess that one up again. And if I substitute that formula, I'm going to go into the right this time. So I have 3 things to choose from, and I'm choosing 3 of them at a time. So, excuse me. You know what? I'm going down. I don't like going to the right. I'm going to go down. Don't know how this is going to work. You know what? No, I'm just going to go to the right, but I'm going to rewrite the whole thing. So we have 3p3 is equal to 3 factorial over 3 minus 3, all factorial, which is 3 times 2 times 1 over 3 minus 3 is 0. 0 factorial is 1. 3 times 2 times 1 is 6. Same as above. Interesting. Now, how many 2-digit numbers can we make? So let's take the numbers 1, 2, and 3 again. And how many 2-digit numbers we can make? Well, let's go for fundamental counting principle, blank times blank. I have a 1 and a 2 and a 3. Let's say I use the 3 and then I have a 1 or a 2, which is 3 options, and then 2 options, which is 6 options. We can list those off to the right, 1 and 2, 1 and 3, 2 and 3, 2 and 1. Excuse me. What are the other 2? 1 and 2, 1 and 3, 2 and 3, 2 and 1. And then, of course, again, 3 and 1 and 3 and 2. When the particular order matters, there are 6 of them. And again, in the notes, you can do permutation notation, which would be, I'm going to use the formula from above. I'm going to put big red around it. So that is 3 things to choose from, P, and we're choosing 2 of them, which is 3 factorial over 3 minus 2 factorial, which is 3 times 2 times 1 over 3 minus 2 is 1 factorial, which is also equal to 6. So again, we can use fundamental counting principle, we can draw them all out, or we can use permutation notation. So again, let's take those numbers 1, 2, and 3. Now, how many different ways can we do it with no restrictions? Well, blank times blank times blank, 3, and I get a 1 or a 2 or a 3. No restrictions. I can repeat 1, 2, 3, 1, 2, 3, which is 3 times 3 times 3, which is equal to 27. And I'm not going to do it, but in the notes you can see how I've written down all of those examples. So again, the big things. Does order matter? Are repeats allowed or not?